Hello everybody, welcome back to my ultimate crash course on AP Physics 1, and today we'll be starting on the first topic, kinematics. We're going to be covering anything you need to pass your unit exam, your unit test, and if you're prepping for the AP Physics exam, we'll also be covering everything you need to know for that, from basic definitions to 2D projectile motion. I wanted to start with the fundamental language of mechanics, which boils down between two words, scalars and vectors. Okay. Well, let's start with scalars. Scalars are quantities that only have a magnitude. An example would be time. Think about it. Time cannot go forwards or backwards. It can't go left or right. It only has an amount. Same with temperature. It only has a reading on the thermometer. It won't have a direction, and not left or right, not up or bottom. Okay. However, with vectors, it has a magnitude and a direction. So examples of vectors would be displacement and velocity. And you'll notice sometimes when writing out the variables for vectors, for example, velocity, usually, they'll write an arrow. And scalars will just be without anything. Okay? Yeah. So I've done my best here to draw a track. And for the viewers who run track and field, you know that a full lap around a track is 400 meters. And so let's say there is an athlete or a runner who is running the 400 meter. And he is in the first lane. If he runs the entire 400 meters and ends exactly where he starts, what is his distance? And what is his displacement? Pause the video to think about this. Well, we know that their distance is 400 meters. Why? Well, distance is a scalar, and it only has a magnitude. So, if you run 400 meters, then that will be the distance you covered. However, the displacement is a bit trickier. The displacement is 0 meters. And I'll tell you why. Because they finished at the exact same spot they started. The change in their position is 0. So their position final minus their position initial is equal to 0. And so when you are calculating vectors, you must always map out your start and end points before you reach your final answer. Now in AP Physics 1, you will encounter many questions about graphs, and to solve these questions, you will need to know how to quote-unquote translate these graphs, especially in kinematics. And in kinematics, you'll often face 3 major graphs: a position time graph, a velocity time graph, and an acceleration time graph. And to solve these questions, you'll need to know what the slope and the area between the line and the x-axis mean. So let's review that. I'm just going to be drawing a positive line, linear line, for every graph to make things simple. And so in mathematics, what do we know the slope to be? We know it to be the rise over the run. So in other words, the y over the x. And that's exactly what we're going to be doing here in physics. Remember, mathematics is a tool of physics. We don't solve problems with math, we solve problems with physics. Math is just a tool we use. So, what is the y? What is the rise here? The rise here is the x. And the run here is the time. And recognize how for every graph, the run will be time. And so x over t is a well-known formula, which is equal to the velocity, which means the slope is equal to the velocity. And if you're wondering about the area from the line, between the line and the x-axis, this right here, in a position time graph, it does not have any standard meaning in physics. However, this is not the case for the other two graphs, for the velocity time and for the acceleration time, but we will in due time get there. Moving on to the velocity time graph, I'll just draw the same line I did for the position time graph, and let's start off with the slope. If we follow what we did for the position time graph, we know that the slope is the rise over the run, so v over t. And again, that is a fundamental formula, which is equal to the acceleration. So ultimately, the slope, or the gradient, is equal to the acceleration. Well, the slope of the velocity time graph, sorry. It's important you have to be specific because we have three graphs stacked on top of each other. We don't know which one we're talking about. And for the area, this part right over here, instead of doing v over t, we do v times t. And v times t is equal to the displacement, because this right here is just a rearrangement of this, right? And so an important thing to note here is when you're calculating the area under a graph, you're actually multiplying the two axes, while when you're trying to find out the slope, you're actually dividing. And usually, sometimes when the graphs are sort of a triangle, as you can see here, they're kind of a triangle, and you know that this is a right triangle. What is happening here? And you know that this is a right triangle, and then you have t and v here. Well, what you would do would be you do v times t over 2, because you'd multiply it as if it was a square and then divide it by 2, because a right triangle is always half of a square. Moving on to an acceleration time graph. The slope is equal to the acceleration over time because of the rise over run, remember? And then that is equal to the jerk. And in other words, jerk is actually just the difference of acceleration. While talking about area, we do acceleration times time, following the pattern we've done for the other two graphs, and that is equal to the difference of velocity. So in other words, velocity final minus velocity initial. And we know this because, again, this is just a rearrangement of this. And here you have it. When graphs aren't enough, we use algebra. So we use algebraic equations. And the AP Physics 1 equation sheet gives you these three primary formulas, only to be used for problems where there is constant acceleration. And we usually call these the big three equations. So let's go through each. The first one, the final velocity is equal to the initial velocity plus acceleration times time. The second one is final position equals initial position plus initial velocity times time plus 1/2 acceleration times time squared. The third and final equation is final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. And when you're solving problems, please do not try to guess which equation to use. Try to hunt for the variables. So every single constant acceleration word problem includes 5 variables: the initial velocity, the final velocity, the acceleration, the displacement, and the time. And so when you specifically read an AP question, you should write down these 5 variables and note down which ones you have, which ones you don't, and which ones are missing. And so usually a problem will specifically give you 3 of them. It will ask you to find one, and it will completely disregard or not mention another. And so we should do a quick example. So imagine Upton Chuck is riding the Great Drop of America. So this great drop seems pretty steep, right? And imagine he's right here and he falls down. And so at Great America, if Upton free falls for 2.6 seconds, what will be his final velocity? And how far will he fall? Well, we want to find the final velocity. We have the acceleration because if you think about it, if he's free falling, that means the acceleration is solely gravity. And we have the time. And we know that his initial velocity is 0 because he's dropping down. So initially he has to be at 0 before dropping. So we can use the first of the big 3 to solve for the final velocity. So we will use v is equal to v0 plus acceleration times time. And then we can do v is equal to 0 plus 9.81, or in AP Physics 1, you can use 10 times 2.6. And that gives us 25.5 meters per second. Now we have one part of the solution, but how do we find the other part of the solution? Well, we don't have the distance, and we're trying to find it. And so we could really, we could use this equation right here, the third of the big 3. So, since we have the final velocity, we can plug it back in here. So we'd use 25.5 squared is equal to 0 squared, which is just 0, so it cancels out, plus 2 times 9.81 times the displacement. And so we'll just square this. So 25.5 squared is 650.25 is equal to 2 times 9.81, which is 19.62 times the displacement, and then you just divide 19.62 by the velocity final, and you would get the displacement, which is 33.14 meters. So up until now, we've only looked at objects drop straight down or kicked horizontally off cliffs. But what would happen if an object is launched at an angle? We'll take a look at the soccer ball kicked. And look, this is an initial velocity vector launched at an angle theta. So in its trajectory, the object is going to be moving up and right at the same time. And because we can't, it's not possible for us to handle the diagonals directly, we have to separate it into 2 components: a horizontal component and a vertical component. And you can see that this kind of turns into a right triangle. And so if we have an angle theta here, and to find these two components, and this is our velocity initial, then we have to use trigonometry. And AP Physics 1 expects you to already know basic trigonometry functions such as sine, cosine, and tangent. So let's look at how maybe cosine, how we could use cosine. So we know from that cosine of theta is equal to the adjacent over the hypotenuse. So if we apply this to our triangle, the adjacent would be the velocity initial of the horizontal direction and the velocity initial diagonal vector. And so if we try to, I'm going to erase this, and I'm going to bring this over here. And so if we do this and we just cross multiply, then the horizontal component of the velocity is equal to the cosine theta times velocity initial. You would actually write this like the other way around. So Vx naught 0 is equal to velocity initial times cosine theta. And that's how you would write it. Now, let's find the vertical component. And I want you to pause the video and think about which trigonometric function we would use to find this component. If you guessed sine, you guessed correctly. Because we have the hypotenuse, the velocity initial, and we want to find the opposite, then we would use sine. So, how would we do this? Well, we could do is equal to the velocity y over the velocity initial. We do the same cross multiplication, and the vertical component is equal to the velocity initial times sine theta. Now, commonly, sine is associated to the vertical component and cosine is associated to the horizontal component, but please do not make your guesses off this. Please actually draw the triangle so you absolutely know, because sometimes they do associate sine with the horizontal and cosine with the vertical. Now, the golden rule of projectile motion are that horizontal and vertical motions are completely independent. And so the only thing they share is time, right? They have the same time. They do not have the same velocity. They do not have the same acceleration. And they do not have the same distance or displacement. Usually, in projectile motion, the acceleration on the x direction is always 0, while on the y direction, it's usually gravity. This is because when we draw out the trajectory, so imagine we have the ball here, and then 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 the ball here, and we draw a little trajectory. So what we get is the velocities like this, get the velocities of the vertical and the horizontal. However, when it reaches the top, the vertical velocity becomes 0. But as you notice, the horizontal velocity is constant. So that's thus the acceleration in the horizontal is 0, while the horizontal in y is gravity. Thank you so much for tuning in to AP Physics 1 Topic 1 Kinematics in a nutshell. And subscribe to be informed when the MCQ and FRQ video gets posted, as well for other topic reviews. Have a good rest of your day.